Hello, myself Dr. S. Selvalakshmi, Assistant Professor of Physics, the Standard 5 Works Rajaratnam College for Women Sivakasi, presenting this video on hydrogen energy. Hydrogen is a clean fuel. It is an energy carrier that can be used for a broad range of applications. It could serve as possible substitute to liquid and fossil fuels. At standard temperature and pressure, hydrogen is non-toxic, non-metallic, odorless, tasteless, colorless and highly combustible diatomic gas with a molecular formula H2. It is the most abundant chemical element estimated to contribute 75% of the mass of universe. On Earth, vast number of hydrogen atoms are contained in water, plants, animals and of course humans. But its presence is very scarce as a gas, less than 1 part per million by volume. Hydrogen can be produced from a variety of resources such as natural gas, nuclear power, biogas and renewable power like solar and wind. Hydrogen energy refers to the use of hydrogen as a clean and versatile energy carrier primarily for electricity generation and transportation. A fuel is a chemical that can be burned to provide useful energy. Burning normally means that chemical bonds between the elements in the fuel are broken and the elements chemically combine with oxygen. For many years, we have been using natural gas in power stations to generate electricity. When natural gas is burnt, it provides heat energy, but carbon dioxide forms as byproduct along with water, which when released into the atmosphere contributes to climate change and global warming. Burning hydrogen does not release carbon dioxide. It offers a solution for decarbonizing industrial processes and economic sectors where reducing carbon emissions is both urgent and challenging. Hydrogen can replace fossil fuels in some carbon intensive industrial process such as steel and chemical sectors, thereby reducing greenhouse gas emissions and further strengthening the global competitiveness of these industries. Hydrogen can be used to power vehicles, generate electricity, power industry, homes and businesses. It could make a huge difference on our carbon emissions and will be critical to achieving net zero. Hydrogen energy is gaining importance as a key player in the transition to a sustainable energy future due to its versatility, clean energy potential and ability to store energy. It can be used in fuel cells to generate electricity and heat, power vehicles and even store energy for later use, especially to balance intermittent renewable energy resources. Hydrogen can be classified into different types based on its production method and associated carbon emissions, often referred to by color codes. The most common types are green, blue and grey hydrogen. Grey hydrogen, the most common type, is also produced from fossil fuels but without carbon capture, leading to significant carbon emissions. Blue hydrogen is produced from fossil fuels but with carbon capture and storage to minimize emissions. Green hydrogen is produced using renewable energy for electrolysis, resulting in zero or low carbon emissions. Hydrogen generation methods can be broadly categorized into thermochemical, electrochemical and biological processes. Thermochemical methods like steam reforming use heat to extract hydrogen from hydrocarbons or biomass. Electrochemical methods such as electrolysis use electricity to split water into hydrogen and oxygen. Biological methods involve microorganisms like bacteria and algae producing hydrogen through fermentation or photosynthesis. Let us now see about the thermal chemical process. So, steam methane reforming, biomass gasification, coal gasification, solar thermochemical hydrogen. So, these are the methods which comes under thermochemical processes. Let us now see about steam methane reforming. This is the most common method for industrial hydrogen production, where natural gas reacts with steam at high temperatures to produce hydrogen and carbon dioxide. And biomass gasification, biomass like wood chips or agricultural residues can be converted into a gaseous mixture containing hydrogen through gasification, which involves partial combustion in a limited oxygen environment. And in coal gasification, similar to biomass gasification, coal can be gasified to produce hydrogen, although this method is more carbon intensive. In solar thermochemical hydrogen method, concentrated solar energy can drive thermochemical cycles that split water into hydrogen and oxygen. Let us now see about the electrochemical processes. Under this process, water electrolysis method and direct solar water splitting method are employed. An electric current is passed through water, splitting it into hydrogen and oxygen, which is called as water electrolysis. And solar energy is directly powers the splitting of water into hydrogen and oxygen using photocatalyst in direct solar water splitting. Let us now see about biological process. The various methods are fermentation, photosynthesis, microbial electrolysis cells. Certain bacteria can produce hydrogen through fermentation of organic matter. And during photosynthesis, some microorganisms like algae can produce hydrogen. And microelectrolysis cells combine microbial activity with electrolysis to produce hydrogen in organic matter. Let us now see the applications of hydrogen in various industries. It is used for transportation. Hydrogen fuel cells can power cars, buses, trains and even airplanes, offering a zero emission alternative to fossil fuels. Hydrogen is also being explored as a fuel for heavy duty vehicles like trucks, cranes and ships. Hydrogen's high energy density makes it a promising fuel for aircraft, with ongoing research into hydrogen powered planes. Fuel cells. Hydrogen fuel cells can generate electricity for homes, businesses and even entire power grids. Hydrogen energy is valuable, transportable and adaptable. As such, it can help lead the energy transition from hydrocarbons to renewable energy resources. Hydrogen fuel cell electric vehicles are more energy efficient than internal combustion engine vehicles. Hydrogen powered vehicles emit only warm air and water without polluting tailpipe emissions. These fuel cell electric vehicles have a fuel cell technology that converts pure hydrogen stored in a tank into electricity to power the vehicle. The driving range is around 300 miles and refueling takes about 5 minutes. In the near future, hydrogen technology advancements could see ships, heavy duty vehicles and even rail transport systems driven by hydrogen. Hydrogen can be used to store excess energy from renewable resources like solar and wind, providing a reliable backup power source when renewables are unavailable. Hydrogen can help stabilize the electricity grid by balancing supply and demand, ensuring a consistent and reliable power supply. Hydrogen is a key ingredient in the production of ammonia, methanol and other chemicals. Hydrogen is used in oil refineries to remove sulfur and improve the quality of fuels. Hydrogen can be used as a reducing agent in steel manufacturing, helping to lower carbon emissions. It is also used in the hydrogenation of edible oils to produce margarine and other products. Hydrogen is used in the process of purifying glass. Hydrogen fuel cells can be used to power stoves and ovens. It is also used as a rocket fuel and in other aerospace applications. It is used in the production of semiconductors. It is also used in welding, annealing and other metal working processes. Hydrogen fuel cells can be used to power medical devices and equipments. In summary, hydrogen versatility makes it a promising energy carrier with applications spanning multiple sectors contributing to a more sustainable and decarbonized future. Hope this video has given a brief introduction to hydrogen energy. Let's meet in the next video. Thank you.